Good morning, good afternoon, and good evening to all our online attendees. Welcome to another seminar in our seminar series at ENGL Hong Kong Polytechnic University. It is my honor and pleasure to be with you today and to introduce our speaker. But first thing first, may I please get some responses and check audio visual connection? Can you hear my voice clearly and can you see me? If yes, can you please write it in the chat box? Or show a thumbs up, whatever works for you, that's fine. Okay, that's good. Thank you very much. So in our first online seminar in this academic year, we are going to hear from Dr. Leigh McDowell from the Nara Institute of Science and Technology. He has kindly accepted our invitation to be the guest speaker of today and tell us about an empirical error analysis of English for research publication purposes, a topic that I know many of us researchers are interested to know more about. But before that, a little bit about our guest speaker. Dr. McDowell is an associate professor at the Nara Institute of Science and Technology in Japan. The institute is a national graduate university specializing in cutting-edge research in the three major disciplines of information science, bioscience, and material science. As such, NIST students are expected to be able to use English productively in their research and future careers. And in order to support this need, Dr. McDowell has been actively involved in the field in English for specific purposes, ESP, for over a decade with a particular focus on teaching and research in the sub-branch of English for research publication purposes. Additional research interests of Dr. McDowell includes error analysis, systemic functional linguistics, and corpus linguistics, all very interesting topics. Okay, we look forward to the talk. As our seminars go, we will have the talk for 40 to 45 minutes with QA to come at the end. However, Dr. McDowell might ask you to engage with his talk during the speech too, so let's have full attention on. And Dr. McDowell, the mic to you. Please start with your ears. Thank you very much, everyone.
Thank you very much, Azar, and greetings from Nara, Japan. And firstly, thank you so much for letting me be here tonight to share with you some of my research. It's really a great pleasure. Thank you, Azar and colleagues there at the Hong Kong Polytechnic University. And thank you all for joining this seminar. It's really great to have you here. It's good to see. I was looking through the list of names and I recognized at least one of them, Professor Noguchi, Judy from Japan. It's great to see you in the audience there, Judy, and all of you. So I hope that this research is of interest and perhaps of some use for you all tonight. So the topic that I'm talking about is an empirical error analysis of English for research publication purposes. And just to be clear, I'm not doing an error analysis of the field of English for research publication purposes. I don't know if there's any confusion there, but this phrasing has now become the established term for the field of ESP, known now as English for Research Publication Purposes, or ERPP. And the work that I'm doing is very much situated in that context, the wider context of ESP. So I'm sure that many of you, or most of you, are aware and perhaps even working in the same field. I'm not sure exactly, the audience. I know Professor Noguchi certainly has been a field leader in that for many years. So it's in the context of ESP and in ERPP. But what I'm specifically going to talk about tonight is an error analysis of the research writing of Japanese scientists, and that is the demographic that I work with here in Japan at the Nara Institute of Science and Technology. So with that in mind, I think I can begin just with a little background here. And okay, so this work is broadly concerned with the issue of accuracy in applied linguistics and in ERPP. I'm sure many of you are aware that accuracy has traditionally been framed in this trade-off hypothesis with complexity and fluency. Goes back to Scan. And I want to argue, I wonder if actually, can I just check that, can you see my cursor on the screen? Are you able to? Yes, okay. So I can use that as a pointer. Yeah, so accuracy, complexity, and fluency, there's always a competition for the language user's attention. And, in general communication contexts, probably fluency and perhaps complexity have received more of that attention. But I would argue that in the context of research writing, that accuracy takes more of the attention because of the stakes, the high stakes of the communication event, also the demand for precision in technical, scientific, or scholarly writing. You also want to establish an authoritative voice, so mistakes would undermine that. So therefore, accuracy has more impact or takes more attention in research writing. At the same time, obviously, it's writing, it's the written mode, so you can build complexity over time with drafting going back and forth, fluency, and it doesn't really matter how much time you take to write research articles, 1 year more. So accuracy, that's all to say that accuracy is very important in research writing and in the field of English for research publication purposes. Over the years, accuracy's been defined, and I just in numerous ways, and I'll just pick out two notable definitions, early definitions from Lennon, 1990. Accuracy is defined as the ability to produce error-free speech, and also as a conformity to a target language norms. And so perhaps neither of those definitions are unproblematic because they tend to point towards comparison with something that's typically a native model or near native model of language. And that has given rise to, for example, the comparative fallacy, Blay-Roman's comparative fallacy, even Philipson's linguistic imperialism. And those kind of views, I think, have been quite predominant in the field of English for research publication purposes, this kind of top-down view of accuracy. So, for example, language standards and literacy brokers, how language standards are imposed on scholars, and how literacy brokers may act as gatekeepers in publication. So this has been quite a dominant strand of research in the field so far, and I tend to look at that view as a top-down view of accuracy. And what I'm interested, though, is a more bottom-up view of accuracy. So how actually, like, for example, how errors impact and play out in the wild. And just one notable exception there is Rozeki and Johnson, who looked at non-canonical grammar You may have come across this article, and they did show that there is some leeway in publication that was within the field of engineering. I'm not sure, I don't remember which exact field of engineering, but there is some leeway. But how much, how much do errors impact? I'm not going to answer those questions tonight, but I am going to focus on errors within research writing, and specifically within the demographic that I work with here, as I said, the Japanese scientists. But I will try to, I will relate it to a more general population towards as we get into this presentation. So let me, if I can now, move on to discuss the motivations of this study that I'm presenting here, because this is important to understand where this is coming from. Over a decade now, I was first employed by the Graduate School of Material Science here at the Nara Institute of Science and Technology. And at the time, I was put in charge of teaching English subjects. I'm a language teacher, obviously. And that's a topic for a separate discussion, although I love to talk about that. I'll keep it focused on errors, because the other part that I was employed, the other tasks that I were employed to do was to provide some kind of linguistic support for the research article output from the Graduate School of Material Science. And so right from the outset, when I first came to work here at NICE, I use that abbreviation, NICE, I had knocks on my door back here, and faculty, also students. I should mention that the students here at NICE are all graduate students, masters and PhDs. Many of them are engaged in research publication. They're all engaged in research. Many of them are actively publishing their research. And so I received requests on a regular basis. Leigh Sensei, can you help us with this research article manuscript? Can you polish up the English, please? That's the phrase I use because that's the phrase that I often heard. Can you please polish up this English? So I was not a co-author or anything like that, but they wanted me to polish up their English, so to try and pick up any errors, any grammar errors. So I was not, they were not expecting me to rewrite these papers or co-author these papers or edit any of the content. Obviously, that's beyond me. I'm not a material scientist. But they had some concerns about the language. And this is not me telling them, you need to polish this up. And this is not, actually, in many cases, I think it was not even reviewers or editors that were asking them to check their English, but rather they themselves were concerned with the accuracy of what they were communicating. They had this genuine need for accuracy in their writing, and so they came to me for that help. And so over the months and years, I worked on many research articles, and maybe hundreds of research articles actually over more than 10 years. And so I quickly learned a couple of things. Firstly, what a high bar they had to success to achieve, to communicate in this really sophisticated form of English, in research writing, academic English. It was really challenging, and I really admired and respected what they were trying to do. At the same time, I realized, well, I mean, it's understandable that you need some support. And of course, this is pre-chat GPT and artificial intelligence tools that we have now. And so I was their artificial intelligence, I think, back in those days. And so, yeah, I realized that, well, this is really, there's this genuine need for this kind of support here at this university, but perhaps not just here. Maybe this is not an uncommon kind of situation in the world of, in the academic world, the world of research. And yeah, so I realized that, and secondly, I realized there must be a more efficient way to do this. There are like 250 of these faculty and students in the graduate school, and although they weren't all coming to me at once, obviously not, they would come in trickles, but there's only one of me, and it's a really inefficient process to be reading all of these papers, and quite a tedious one too, I might add. This is not my research field, and I was just sort of reading for coherence and for grammar mistakes, essentially. And I was seeing the same mistakes coming again and again. And I got to thinking, just about a year or two in, there must be a more efficient way to do this, and I should do some kind of research. For example, if I knew exactly what the most frequent errors were in this data that I'm working with, then I could provide the education, which is really what I'm really interested in, is in the actual education. Then I could provide the pinpoint education to be able to target those needs. This is an ESP approach. In the classroom or in outside the classroom, or for whatever, I could tailor support to really be able to help these people more efficiently identify their errors and perhaps even overcome them. So that's the motivation. And then I posited this research question, which was, what are the most frequent sentence-level grammar errors in the research writing of Japanese material scientists? And perhaps I can add material scientists. I'm not sure if you're familiar with material science, but it's a rather interdisciplinary field or discipline which spans like physics to chemistry. It's got bioscience in there. There's a lot of device science and engineering. It's really a fitting proxy for physical sciences at large. So material science is a kind of representative population of physical science. And just to make it clear, this is not social science, and I think probably all of us here in the seminar are familiar with research writing in the social sciences, coming from our field of applied linguistics. There are important cultural differences in physical science. One of the things that I found initially was that the focus is on the data, on the data rather than the argument. So I think that in applied physics, we're much more comfortable and with the language, and we tend to build our arguments. Our research articles can be up to 10,000 words. Perhaps that's common. I think around 9,000 words is quite common. But material science tends to be shorter, more to the point, and the focus is there more on the data. So yeah, I hope that motivation and that research question is clear. And so let me move on there, I guess we're getting into the procedure now, and starting with the participants. So, okay, so I want to know what are the most frequent errors in this population. And so I got a sample of 53 participants. And these participants were faculty, professors, and professors, associate professors, assistant professors, and also students, mostly PhD. The master's students here don't tend to publish. They tend to present more, and it's not until they get into the PhD program that they might start publishing their work. So I had a mixture of what I call early career, that would be the students, the graduate students, and established career students, which would be the faculty. So that's the distinction there. And I thought that distinction might be interesting. Do these two groups have different eras? So I tried to actually get an even number of participants in both of those categories. And you can see just the breakdown of the ages here. They're mostly younger, but a few, probably the older would be probably the more established professors. And it's mostly males because that's actually what the demographic is here in materials science. So that's that kind of common pattern, I think, in STEM that really plays out here. So that's the participants, and what I was able to do was, because I was working directly with these people, working on their research article manuscripts, at the end of the process, after we'd finished the proofreading, I would ask them, do you mind if I use this research article manuscript in my own research? And they were most of the time very happy for me to do that, especially when I explained the motivation behind it, the reasoning behind it, what I was looking for. They were more than happy to let me use sign consent to let me use their research articles. So what I did was collect one research article manuscript from each of these participants for a total of 53 texts, 53 papers. And let's look now at the corpus preparation. So with these 53 papers, I was able to assemble a small corpus, very small corpus, the corpus comprised of these research article manuscripts that had already this notation, this error annotation as part of the text. So what I had here was, after the drafting process, which the participants did themselves, they would come to me for this, I'll call it copy editing because it's slightly different to proofreading, technically different to proofreading. And so I would work on the paper sometimes together with them and then pass it back to them. And then they when they were satisfied, they would pass it on for peer review and eventually publication, but then it was out of my hands at that point. So what I had essentially with this error annotation is really a before and after versions of the texts. And actually, I'm in the process of publishing another paper more specifically on this corpus with the journal Corpora through the University of Edinburgh. That's under review at the moment, so I talk more about that in that paper. But just for the purposes of this presentation, you can see that this is Microsoft Word's error annotation or editing tool. So it's using strike through and underline. So you can see that something here has been deleted, and then something's been added here, and you can see this kind of annotation here, and that's basically what we have to work with. Okay, so that Microsoft, very simple, in fact, just using Microsoft Word. And actually being simple was important for me because I was thinking, what kind of method can I use? What's a simple method that I could use that perhaps other language teachers like myself would also be able to copy? So Microsoft Word is pretty much a common tool, I think, within the field of language teaching. So I just stuck with that. And I'll just give a little a little theoretical background here or framework on the what can I say? The research, the branch of research known as error analysis. I'm not sure if this is familiar, if you've come across this. It's now mostly a footnote in the history of applied linguistics. It's no longer an active branch of research in applied linguistics, but there was a time, and the time was when second language acquisition, the field of second language acquisition was just emerging, that these early SLA researchers were very much interested in errors as a window into the processes behind language learning, language acquisition, I should say. And they used this banner error analysis was the word that was used to describe this kind of work. There was not one established methodology. There was a whole bunch of people were doing their thing. But one, I think, notable exception is Pitt Corder, way back, established an algorithm for error analysis. Sorry about that. Yeah, but I think it's important to note that there's not a truly established error analysis. So when I use this error analysis, I'm typically talking about the field, not one particular methodology. And looking through that field in those days, there was a lot of taxonomies that came out of this research, how to categorize errors, quite a lot. And the one that stood out to me that I took on board for my own research was what's called the surface structure taxonomy from Leigh et al. I think Stephen Krashen was part of this team, and they found that grammar errors could be described in 4 error types, could be boiled down to these 4 error types: omission, addition, selection, and ordering. I'm not sure if you guys have come across this. I'm curious. I'll just, if it's okay, let me ask in the comments, perhaps. Are you guys familiar with this taxonomy of errors? Has anyone heard of this? Has anyone come across this? Okay, so I'm not the only one. Thank you. Okay, so it's not unfamiliar. That's interesting. Yeah, it was new for me at the time, but then when I think about it, okay, so something can be omitted, like here, for example, the definite article was not there, and it should have been there. And here it was there, but it should not have been there, so that's an addition error. And then the selection error, when something is there, but it's the wrong thing, so it's misselected. And then there can also be ordering errors. And what I was surprised to find actually in my research was that this taxonomy, this simple taxonomy, really holds up, because I could categorize every error, pretty much every error, except for spelling errors, in this way. And in this way, it's a real bottom-up process rather than top-down. So rather than, here's the error categories, we just look at using these 4 I'll call them error types. Using these 4 error types, we can describe all errors. So this is what I've used. And let me move on now and explain the coding, the way I've coded the data in my research. And just imagine a spreadsheet, an Excel spreadsheet. As I mentioned earlier, I use Microsoft Word, really freely, not free, but commonly available tool, and Microsoft Excel, another commonly available tool in our repertoire. And this is basically all that I used. So you can imagine this is a spreadsheet here, and what I've done is copy-pasted sentences. I've taken sentences from the texts and pasted them into a spreadsheet, into a column in a spreadsheet. And the advantage of that is that, well, I have it in a spreadsheet to do the coding, but also because Microsoft works together, the annotation from the Microsoft Word document is copied over and stays intact in the spreadsheet. So this is beautiful and makes my life easy. Although this coding process, I should mention, is far from easy, but there are the errors, and these are in sentence forms. By the way, the sentence was the original unit of measurement in error analysis research paradigm. So I was okay to stick with that. It made sense. And then what I would do would be firstly to label the text so that I know where these errors are coming from. And these labels, by the way, JR refers to junior, and I also used SR to distinguish senior. That would be the established career participants from the early career participants, so I could just keep an eye on those. So there's the labeling, the text, just a text number and that labeling format. And then the error types. So I would go through and I would look and, okay, so firstly, that was omitted, so it's an omission error. And then I'm coding the actual error. Because it's an omission error, so that was omitted. So there was nothing there. The error is 0. This is also borrowing from this early error analysis research paradigm. If there's nothing there, it's coded as 0. And then they would call this Corda would call this the reconstruction, the error reconstruction. Maybe language teachers might be more familiar with the correction. It's the correction, but it's just a different framing. So that is the reconstruction. And yeah, actually, you can see that sentence is repeated because there are 2 errors, so it's just duplicated, and this doubling up just helps me to recognize that that's a duplicate, so I can count individual sentences. And so, for example, in this error, maybe I can zoom in a little bit. So is was misselected for R, and so it's a selection error, so the error was is, the reconstruction was R. And then in this way, I do that first level of analysis. And then importantly, I think it's important to emphasize this, I also included parts of speech coding as part of the coding process. And I was able to kind of automate this by using Lawrence Anthony's TagAnt program. And so that will, based on the University of Pennsylvania tree bank parts of speech taxonomy, that will give you these little tags. And I just copy pasted them in here. So I know the actual error, I know the error reconstruction, and I know the part of speech of both the error and the reconstruction. And this is, maybe I'll explain later, really helpful to broaden the view of the analysis. Okay, so I hope I've still got everyone coming along with me. Everyone okay? Are you guys, you're still out there? That's the problem with these online presentations. I can't see anyone read the room, but I'm assuming that you're all following along. Thanks, Azar. Azar gives a thumbs up. Okay, let's move along now, and we can look at the corpus, the overview of the corpus, and early results, initial results. Okay, so as I mentioned, there were 53 participants, 53 texts, in the corpus. So 53 participants, one text each, 53 texts, and I just abbreviated this table so that it would fit. But let me go through some of this data, walk through it with you. So firstly, the word count of each text. You can see 3,000, 4,000 words, 2,500 words. So these are shorter research articles. By the way, the figures and tables have been removed, and so this is only the text. And it's a total of 152 words, which it's a small corpus by corpus standards, obviously very small corpus. However, the weight of this corpus is really here in the number of errors. So it's easy actually using Microsoft Excel. It's easy to quantify the number of errors. You just look at how many in each text, how many rows. And you can easily quantify the errors, and there is a total almost 4,500 errors in the corpus. So that's more than enough to get an empirical view, to get a good idea of what's going on in the data. Okay, what else can I point out? So this is important, the normalization of the errors per 1,000 words is 29 errors per 1,000 words. So this is, I think, gives us an initial insight into this population, that they typically have around 29 errors per 1,000 words. What that looks like, to give you a more concrete framing, you probably know that one A4 page is around 500 words. So this is like 2 pages, 29 errors, which is around about 13, 14 errors per page. And so just with that, you can see very clearly that you can understand very easily how these scholars might feel uncomfortable about presenting their work like that to reviewers and editors and readers, and are looking for this kind of linguistic support, because that's a lot of errors, I think, and that's what I found. That's in the data. Okay, and then this is the coding by those 4 error types that I described, so the omission, addition, selection, and ordering. And you can see that the selection errors are by far the most, followed by omission errors, addition, and ordering errors are much, much less. And then interestingly here, I just made a category for other errors that didn't fit into those 4 error types. Only 41 among the whole among the 4,500 errors. So as I mentioned earlier, most errors can be coded. Almost all errors can be coded using these 4 error types. They would probably be spelling errors. Okay, so that gives us a little bit of an insight into the data, but omission of what? Addition of what? Selection of what? This is what we need to know. And I'll get to that, but I'll just make one more point about the representative power of the data. Here you can see a histogram of both the total words per text and the errors per 1,000 words. Both of them appear normal, and then if I do the analysis, they check out as a normally distributed data sample. So that lets us make some inferential claims. For example, when I look at this is the number of errors. This is the number of errors, normalized number of errors per 1,000 words for established and for early career and established career. As expected, the early career scholars tend to make more errors than the established career participants. That sort of stands to reason. However, I did a t-test on these 2 sets, and there is no significant difference. So I can't actually say that early career material scientists tend to make more errors than established career which, okay, so what's going on there? The way I interpreted that, actually, I was quite interested in this, and I did a whole separate study just looking at the practices, the writing practices of this population, which I've published elsewhere. And it turns out that they're actually collaborating, they're constantly collaborating, and it's the collaboration is typically with the professor and the student co-writing. Sometimes the student will write the paper and then go to the professor, and the professor will rewrite it, or other way around sometimes. And so actually, it's not a clear distinction, like this is the student's written this paper and the professor's written this paper. More often than not, it's a collaborative effort, and so in the end, there is no clear distinction. So I think that probably makes sense and probably resonates with a lot of you. You know, the students don't just, the students will typically be working with their supervisors on these papers. Okay. So, okay, now I think with that noted, we can move on now to look at the, I think this is the crux of the matter. This is really the meat in the sandwich, so to speak, the profile of the most frequent error patterns. And this is really actually the answer to my research question, which, if you recall, was what are the most common, the most frequent errors in the research writing of Japanese material scientists. And this is really the answer, because this is a list of 10 of the most frequent errors in the data. And these 10 errors account for 53% of the errors in the corpus. So this is more than half, or it's half of the errors in the corpus. Incidentally, if I go to the next rank down, so the next 10 most frequent errors, and then the next 10 most frequent errors, these combined with the first 10 take it up to about 62%, something like that. And then it just goes, 65%, very much diminishing returns, very much a flat curve. So these top 10 errors really comprise the most frequent errors in the data. So let me look at these and talk about these with you here for a few minutes. So the number one most frequent error pattern is the omission of determiners. So for example, the was not used when it should have been, when it should have been. It would have been better to have used the. And that's probably no surprise, certainly for anyone that's worked with Japanese populations and Japanese scientists. Determiners, articles, they are troublesome for this population. Japanese doesn't have articles, and it's very much foreign, the concept, and it's a real struggle. Also, it's really also, if I'm being honest, it's an artifact of the frequency of this part of speech coming again and again and again and again and again, because it's actually, you probably all know that the is the most frequent word in English language, so it's no coincidence that it would be the first one to appear on this list. And similarly, the addition of determiners. So, this is indicating that sometimes they miss it, sometimes they add it in when they don't need it. And it probably indicates that, articles are not acquired, that they haven't acquired this particular corner of the grammar and they're struggling with it. Prepositions feature heavily. In fact, I think it's, so if I can't do the count, so determiners 1, 2, 3, and then prepositions 1, 2, 3. So 6 of these top 10 errors involve determiners and prepositions. And again, that's no surprise. Determiners, prepositions are the other things that are, 1, very frequent in English language, and 2, quite opaque and not easy to acquire. So there's a lot of misselection of prepositions. There's sometimes the prepositions have been added. This is an interesting one. So, for example, the desorption, the aid of desorption of ligands, of. So Japanese scientists love to use the of as a kind of a hack to build their noun phrases. And maybe it's not actually technically an error, but it adds up and certainly detracts from the writing, the impact of the writing. There's the singular and plural nouns problem. So there's the misselection of singular for plural noun. And so rather than sharp edge, it was actually sharp edges. And maybe just to make the point, it's not so important, is it? Sharp edge, sharp edges. Likewise, you miss an article here and there. It's no big deal, right? Right. However, in research writing, where the issue of accuracy becomes more salient and precision is more important, these things can impact negatively impact the writing. And just one or two, no big deal, but they're compounding over time. As I said, 29 errors per 1,000 words, or 13, 14 errors per page. They're compounding, and this builds up to some confusion within the reader, the reviewer. So, a sharp edge or sharp edges, it's actually, it's important. That's information that's missing. So, yeah, determiners, prepositions, perhaps no surprises. Actually, punctuation also features quite heavily. You can see omission of punctuation is the fourth most frequent error. And then there's also selection of punctuation errors. And I understand technically this is not a grammar error, is it? Punctuation may be outside of grammar, but it was in the data, and it came out in the data, and it was there, and it's clear that these population, or at least the sample that I measured, is struggling with punctuation. That punctuation is a technical issue. Now, again, who cares about punctuation? I should be careful about that, because I guess many of you are English teachers and you care deeply about punctuation, I'm sure. But in communication, it's minor. It's a minor thing. But again, technical writing, scholarly writing, these things become more salient, and there is an issue there. Okay. So I'm kind of running out of time here, so I won't be able to go through all of these long laundry list of errors. But I think just to make one more point, that there are no errors with verbs until down the list here, number 14. So errors with verbs don't appear until much lower down the list, and much lower in frequency. That was surprising to me, because I think we would all expect, subject-verb agreement errors would be there, tense errors would be there. But in fact, they're there, but not to the extent that I expected. And so what's going on there? Perhaps I thought about this, obviously, and I think, for one, this is one fairly rule-based area of grammar that, like, for example, a Microsoft Word spell checker, grammar checker, can actually pick it up. And so they're actually picked up before they come to me. Those errors are because the squiggly line, the Microsoft Word squiggly line, I think, will indicate that there's an error there, and you can correct it. So I think that's part of it. It also may indicate that, as in terms of language acquisition, that actually that they have a better handle on tense and aspect and of the verb systems in English. Okay. I'm running out of time, so I will perhaps wrap up and move on to discussions. And I did have two separate studies, sub-studies in reliability, inter-rater reliability. So I looked at the reliability of the data that I just presented. I wanted to build an empirical case for this profile of errors, and so I hired two additional raters to check a subsample of the corpus, and I can present that data if you're interested. And also, I think this is probably more interest to you, is that I compiled another. I ran another sub-study of non-Japanese scientists to try and compare their types of errors, and I could only get 6 people for mostly logistic, practical reasons, but I got these were material scientists that working here in this department, in the Department of Material Science, but they're from other countries. So one was from China, one was from Thailand, one was from Germany, one was from Egypt. What was that? And another 2. Sorry, I can't remember off the top of my head, but I looked at their error profile as well, which I can talk about if we have time. But yeah, what I found was that it does actually, maybe I can just leave you with this point, in terms of generalizability. Okay, so I'll make this the final point. So from that sub-study, the data of the 6 additional non-Japanese scientists, I was surprised to find that they have mostly the same errors. So the omission of determiners, this is in the original data, that corpus of 53 articles that I checked. It was number 1. Again, it was number 1. The punctuation also appeared in the non-Japanese data quite highly ranked. Determiners, again, the selection of singular and plural nouns are there. So they're not in the same order, but this gray indicates the overlap. So 1, 2, 3, 4, 5, 6, 7, 8 of these errors are also in this original corpus. These 2 are not in the top 10, I should say. They're in the top 10. These other 2 additional errors were not in the top 10. So this one was in the top 11, and this one was much lower ranked. But it just indicates to me that actually those errors that I've uncovered in this study may not be peculiar to just Japanese scientists and may actually affect the wider population of scholars engaged in publication. Okay, so let me conclude my talk here with just some salient points. Errors in the corpus that I analyzed occur at a rate of 29 per thousand words. The top 10 most frequent error patterns comprise 52% of all the errors across the corpus, and the 30 most frequent error patterns account for 63.2%. And I will note that the part of speech coding actually helps get a wider view of error patterning. So some of those error patterns would not have shown up in the data. For example, misselection of singular for plural will not show up because it's a different word each time. But when you analyze it as a part of speech, it shows up as a more frequent error. And this actually, these results that I've noted here tonight are consistent with previous studies. So again, no surprises. Determiners, prepositions cause trouble for Japanese population, not only Japanese non-native populations. And then this would be my last point. Findings from this study can be applied to inform specialized ERPP pedagogy aimed at better supporting Japanese scientists and possibly others in dealing with errors in research writing. This is really where I want to go with this study, is to be able to incorporate it into my teaching, which I do, in fact, because I teach research writing, and I actually I now include some focus on these errors and give them some support, how to recognize and address these errors. So it's been quite helpful so far for me. Okay, so I think I can leave it there with the references, and I'll give you some links here for those who are interested. If you want to access the slides, I've uploaded them to my LinkedIn page, my LinkedIn profile. I just did a post here this evening. And also, a study that I presented was published in the Journal of English for research publication purposes. You can access it here. It's behind a paywall, but I also have a private version on my ResearchGate page. If you don't have institutional access and you connect with me there, I can pass it on.